Okay, binomials by binomials. What's our first binomial on this one? X plus 3, right? It's got two terms. Your second binomial is x plus 2. We're starting off today's lesson the same way we started off yesterday's lesson. The picture's already drawn out for you. This one over here is the x plus 3. This one's obviously the x plus 2. You multiply it the exact same way. So pictorially, our steps don't change. As long as you draw it out properly, you'll be set. What's our first one going to be? X squared. So it's going to be one of these. And it's going to be positive. What are our next things over here going to be? 3 positive x's, right? That times that would give you a little x. And these. And you're going to have 3 of them. That's simple enough. Now we got to work our way down this way. Let's just chill out. Not 2 x's. Okay. So you're going to have 1 x there. You have another x over here. And 6 positive ones in the bottom right corner. Pictorially, it's the exact same process as yesterday, so it shouldn't be any more difficult. It's just a little more time consuming because now we have more things to multiply. Yeah.
Can you just draw the lines there? Draw a line between, like, on the side between x and the y, between the one and the one.
Okay. Yeah, you can do that. Yeah, that works. If that's the way you like it, that works. This one. Oh, I guess we need our answer. So what's our final answer? Is everything inside? Yeah, Taylor?
X squared plus 5x plus 6.
X squared plus 5x plus 6. That's just everything we have in there. Our x squared, we have 5 of those, and we have 6. Perfect. Good job, Taylor. To the next one?
I just got confused with what I
You're in the brackets? Okay, I see. So, we have to fill in the brackets this time, right, Murph? So, you fill in the first brackets. What is it?
It's going to be 2x. Okay, never mind. I realized that's 2x.
That's a lot, Murphy. Murphy, what is it?
I thought we were going to do it pictorially, but wouldn't it be x plus 4?
X plus 4. So he's given me that one. So x plus 4 is the first binomial. There's 1x plus there's 4 individual ones. So in the first set of brackets is x plus 4.
No, I thought it was that. I thought the top one was supposed to be second.
Doesn't matter. You can put the top one second or the top one first. So if you like the top one second, cool, that works. Multiplication doesn't matter the order, right? Matthew.
What happens if we're multiplying x?
We'll get there. Yeah, that'll change. Go.
I realized what I did wrong.
Okay.
I got that.
Good stuff. So what's the second bracket going to be? We're doing additional now. 2x plus 1. So we filled in our brackets. Now we have to do it pictorially. You guys should get this. And this will be stuff that I believe you're expected to do on pen and paper on your phone and your unit. That should be the answer you were able to get.
2x squared plus 9x.
2x squared plus 9x plus 4. Exactly. Joe's got it right. So he realized we have 2x squared. We got 1 2, 3, 4, 5, 6, 7, 8, and 9. Don't forget this one down here. They're all positive, Rachel. And then 1, 2, 3, 4 singles. What would be your final answer?
Jojo.
Did I lose you?
+1.
+4. Yeah, you're good. Use algebra tiles to illustrate this one. We have negatives now, so it's going to throw us off a little more. Negatives and binomials make it a little bit more challenging. So it's not quite as standard. So, the first one, we need two x's, and we need -1. That's our very first binomial. Our second binomial is just going to be 1x plus 2. Multiply them the same way that we've done all of them. X times x, and then x times x. Those are going to give you 2x squared. What do we put on this last row, though? Carter? A negative x, so a negative all left. Down here, we're going to have a whole bunch of x's. X. X. And what's our bottom right corner going to be? Taylor? Negative ones. Yeah, the little individual boxes. So -1 and -1. Everybody agree with the picture? Then what's the answer?
2x squared plus,
Yep, 2x squared plus, Taylor?
2x minus x.
2x squared.
Minus. Yeah. Plus 2x minus x.
Plus 4x minus x is, if you have 4 minus 1 is plus 3x. Yeah, you got it. Minus 2. There. Go.
So for like execution because
Yeah, so you had 1, 2, 3, 4, but then you had -1. So it cancels one of them out.
So you don't
So you take off the fourth one, take off that one, right? 4 minus 1 would be 3. Like,
have to put the canceling out with your equation.
no, your answer. If you can do that in your head, don't worry about it. If you put it in your equation, it just means you have to simplify your equation after. So you would have had 4x minus x. Just combine them, right? Any questions about binomials? Look up there. That's one way to do it, pictorially. Another way to do it, area diagram. This will work for any polynomials times any polynomials. So it's nicer for binomials because it's a nice little square, but it does work for everything. So what we did was we put our first binomial along the side, our second binomial along the top. And we did the same thing, just instead of pictures, we use the actual numbers. So let's just jump right in and give it a shot. So the first one down the side, 5x. And then we have a -6. The 2x minus 1, we're going to put on the top. Any questions about that? If you fill in the boxes incorrectly, then it's all going to go crappy on you. You have to put the negatives in. That's the key. So that -6, the negative stays with the 6. If you lose the negative, it will throw off your entire answer. Now you just go to each individual spot. Go row times column. So this spot right here. The row is 5x, the column is 2x. Multiply those together. What do you get? 10x squared. The 2 times the 5 give you the 10. X times an x gives you x squared. So Matthew, the next one over here. Negative 1 times 5x gives you negative 5x. So you multiply the coefficients. Bottom left. Carter, negative 12x. Negative 12x. And what's the very bottom right? 6, right? The negative times the negative. Gives you a positive. Joe.
For the two middle ones, because they're like three are together, so it'd be like
Hey. Keep going. You're right.
it'd be whatever. So it'd be like 10x squared minus 7.
So we got 2 questions. These x's are the same, so we're going to have to combine them, right? The other question is down here, this 6. Should it be negative 7 or should it be 6? It's multiplication. So it's negative 6 times negative 1. Right? Addition would have been negative 7, you're right. But it's multiplication. Now you take everything on the inside, and I wish I could see. And you put everything together. So, how many x squareds do we have? 10x squared. How many x's do we have? Negative 17 x's. And then how many constants do we have? That's the plus side.
So it's sort of like what we did with like the shapes. What I said that you said with numbers.
Exactly. It's exactly the shape thing, just using numbers. Would it help? Try the second one. I'm going to erase this answer. Everybody got that written down? Hurry.
Instead of A, you use or instead of X, you use A.
Great, so does that make a difference? No, makes no difference. You treat A's just like you treat your X's. You're good? Thank you. Make the exact same chart. You're going to go A squared, and you're going to go 4. A squared and minus 5. Do the exact same thing, but now we got that question Matthew asked earlier in the class. What happens when we have a squareds times a squareds? Pictorially, how would you represent that? You couldn't. We don't have a picture for a to the power of 4. Do we? No, we don't have a picture for e to the power of 4. So this question pictorially would cause some problems for you. So I think it hurts people's eyes. So a squared times a squared gives you what, Bert?
A squared by a squared gives you a 4.
A to the power of 4, yeah. You just add the exponents. Oh, it is also multiplied, but don't multiply the exponents. 2 times 2 is obviously works out nicely for you, but it's addition of the exponents. What's the next one, Michael? Let's just walk through. So we're going to multiply this by this. Yeah, so it'd be negative 5a squared. So when you take the constant, it has no variable with it. Yeah, you times it by the coefficient here. What's the coefficient? It's 1. If there is no coefficient, it's 1. Negative 5 times 1 gives you negative 5. Your a squared is still a squared. So bring it down here. Same question, try again. 4a squared. And the bottom right corner, Kendall, what do you think we get? Negative 20. Correct. Combine it all together. should give you a4. Sorry. A to the power of 4. Negative 1a squared. You can just leave this negative a squared. And minus 20 still remains minus 20. This last one over here. Same thing, but now we got two variables, right? It's going to cause another problem. We got 3p and 2q. I'm going to run out of room on the side of the board. On the top, what do we put, Gabby? Yeah. Q, you got it. First box. That's an easy one. 3p times 4p is 12p squared. The 12 comes from the 4 times the 3. The p squared comes from the p times the p. Murphy.
I get that, but why does p why do exponents add
When they're lonely?
No, like when they're either say you have like p squared and then you just have p squared.
Okay, I'm going to show you. Ready? P squared times p squared. You're asking why do we add the exponents? Okay, so if we had p squared, it's equal to p times p, correct?
Yeah.
The other p squared also equal to p times p. So if we wrote those things in here individually, it's safe to say it's equal to p times p times p times p, correct?
Yeah.
What's that in exponent form?
P4.
P to the power 4. That's why you add the exponents instead of multiply them. When you break it down to 1 times 1 times 1 all times each other, you just add them up just like that. So we can simply just say 2 plus 2.
Well, it's multiplications like p times p. Just because it's 1p. It's 1 times 1.
It's not 1 times 1. It's 1p times 1p. You're right about the coefficients. They're all going to stay at 1. That's why the coefficient here is still 1. Right? So the coefficient is still 1 because it's 1p times 1p. But the p's are still times each other, which gives you p squared.
Kind of makes sense, but it kind of doesn't make sense.
We'll go over it a little bit more later. This bottom one here, that's going to be our first confusing one.
I'm so confused because I was like first one plus the top and second.
Yeah. As long as you come to the same things in the middle.
8PQ.
8PQ. Dawson, do you agree? Okay, why is it 8PQ, Dawson? Yep. Makes your PQ. Right, because P is its own variable and Q is its own variable, so you can't do anything with the exponents. Emma. No, 8 is a, you could reorder P and Q if you wanted, right? You can even reorder the 8. So the 8 is a coefficient to both the P and the P. And this top right one would be negative 3PQ. Good job, Joe. And this bottom right one would be Dawson. Negative 2Q squared. You add them all together. I'm out of room. I'm going to put it up here. You would get 12P squared. And then you would get plus. That's a 3 there. That's an 8 there. So 3 plus 5. Yeah.
Is this like different or so?
Just wait. Go ahead, Joe.
We need to do like terms. So P squared.
Okay, that's a good question. So that's where the problem comes from. When we do our like terms, it's your variables. So do we have p squared anywhere else? No, so it's just by itself. But we do have a PQ and we do have a PQ. Right, Ella? Okay, so you combine those. Those are like terms. We have a PQ here, and we have a PQ there. We don't have PQ anywhere else. Dawson.
What about the negative 2?
So that can go on its own. You just never got to finish it. Dawson. So
Like, you mean like it's being like 5 Q, is that what you're saying?
is that what you're saying? So you say negative
That's
2.
what I thought you were saying.
I think you're saying this.
Oh, yeah.
Are you saying like that and then plus?
Yeah.
That's a good question. So Murphy gives us some insight to the issue. How do we write our answers, Murphy? In descending order. But then the next question is, how this is still descending order. We just used our q squared first, right, Dawson? Okay, so
But when you think about it,
you go alphabetical. So when you, no, that's the reason. When you have, they're both squared, so they're the highest, you go alphabetical. If they're tied, go alphabetical.
so then,
P comes before Q,
oh,
right? So you're going to do your P squared first. Matthew.
If it goes alphabetical, would you like imagine it was QP, would you supposed to be in Q?
Nope, because you wrote these ones alphabetical as well.
Oh,
P, you wrote those ones alphabetical as well, just like you would with AE. That's a column one you'll see. PQs, I hate PQ.
never mind.
Emma.
If you're dividing it into something squared, then you do squared minus 2Q.
yeah,
That's the next question. Okay. Okay, so you're trying to say that Q squared goes here.
yeah.
Okay, so whichever one you choose to go with first, Matthew, this is important. Whichever one you choose to go with as your first term, you go descending from that variable. So if you use p squared as your first one, it's descending in terms of the p's. So then the next lowest p would be here with the 1, and the next lowest p would be here with none. Perfect.
So if I were to put 12p squared and then 12apq and stuff, and it wasn't in descending order.
No, I give it to you.
I was about P.
Yes, sir. You can also use multiplication for your 2-digit, but we're going to try to, we don't have time for that. It's the same steps, you just use coefficients. You're about to miss out on FOIL. Okay.
Foil.
Your best friend.
Made foil my baby.
Okay. FOIL. So this is the third way to do it. Remember our distributive property from yesterday? Distributive property was easy when it was one thing. Now it's binomial by binomial. So what you need to do is you need to take each individual thing, that has to multiply by that and that. That has to multiply by that and that. So you're distributing everything. So this x goes here and there. And that 2 goes there and there. And a simple way to remember that you always multiply everything is FOIL. FOIL means first, outside, inside, last. And it's talking about the terms. So it says multiply the first terms. That is a first term and that is a first term. The first term is multiplying our x times x gives you x squared. The inside terms refers to the actual the middle 2 terms, the inside terms. That's an inside term, that's an inside term. When we multiply those together, we get plus 2x. Outside term. the opposite of your insides. So it's the two outer terms. That's going to be plus 3x. And last. That's for each individual binomial. 2 is the last term in the first binomial. 3 is the last term in the second binomial. Gives you plus 6. Matthew.
Can you just add them all together like I should do?
Ooh, what do you mean?
Like
So you did your,
Oh, geez.
like your 2x and your 3x?
yeah, just like.
Yeah, if you can mentally just understand that some terms are going together, go ahead, Matt. Writing it like this is a surefire way to not make a mistake. Perfect.
If I feel comfortable, like, you know how when people have two polynomials, but they're on both sides, versus directly from each other?
Yeah.
If I feel comfortable just